I hope you guys are doing great. So in the previous video, what we did is we discussed a few reagents that are important for you to do your synthesis problems. But today, what I'll do is I'll run you through a few synthesis problems and what you're expected to do. So the first question here wants us to synthesize this. So we have 2-methyl-2-butanol. So the first step, whenever you're given the question wants us to synthesize using Grignard reagents. So the first thing you need to do is you need to draw this. So we look at the parent. The parent is butanol. So that's 4. So 1, 2, 3, 4. First step. And the second thing we'll be able to see is at position 2, there's an alcohol group. So we'll be able to put the alcohol group there. Right, and at position 2 again there's a methyl group. So this is the structure they want us to synthesize. This is the what do you do when you're asked to synthesize such? So when it comes to synthesizing such, there are many ways, there are many approaches you could take. Let me show you how to analyze the approaches. So the first step, draw the compound on a separate piece of paper, and then think like this. So when you take this as being the center, how many groups are attached to this molecule, to this compound? So that we have an OH group, we have an ethyl group, and we have 2 methyl groups. So 4 attachments, right? So what we do is you need to cut the compound in such a way that you need to have 3 parts. So in the first place, I could have these 3, right? So you're looking for 3 parts only out of the 4. I could have this, right? So how many possible synthesis methods are there? 3 possible synthesis methods. So that's how you check for the synthesis method. So let's use the first one that we figured out. So our compound looks like this. Right, so what I could do, firstly, I'll get these 3 parts, right? So when I get those 3 parts, switch this with a ketone functional group, so it will look something like this. So you have that part there, you have that part there, and then you have that part there, right? I've taken out this part. I hope we're able to see what's going on. And so if I wanted to move from here to there, what would I have to do? I would have to add something, right? I would have to add an ethyl group, and then the only way you can add that ethyl group is if your Grignard reagent had an ethyl group like this. And then when you run this reaction, one thing you'll be able to see is this carbon here is negative, and so it will attack this position here. And once it initiates that attack, the final result will look like this. So this ethyl group will join in there, and then we'll have something like that. Right? So this part here has joined, and then we have this, right? So since we have this, there'll be a problem here. This carbon will be connected to 5 things, 1, 2, 3, 4, 5. And so the best way to avoid being connected to 5 things is if this happens. When that happens, it will be negatively charged, and it will attract the magnesium bromine like that. And then one thing you see them do in most books is that they'll also add some hydronium ions. What's the purpose of the hydronium ions? In order to convert this into an alcohol. So your final product, how will it look like? You have something that will look like this. You have an OH. As you can see, we've gotten back to where we're supposed to be. So the first thing I did is I got these 3 groups. So the second way I could do it is I could get these groups here. right? So let me draw that for you like this, like that, right? So I could start there. So if I start there, I replace this with a ketone group. So I'll start like that, and then I'll add. What do I add? So I need to add a methyl group. So the Grignard reagent to be attached to a methyl group, it will look like that. And then when that reaction happens, this methyl group, this carbanion will attack there. And then once it does, our resulting compound will look like this. Same story. This becomes negative, it's attached to the magnesium bromine. If you watch the previous video, you'll be able, this part will make a lot of sense. And then if you use some of your wake up hydronium ions, they could provide an OH, and then finally you have an alcohol we've gotten back. And then what's the last way? So we had we did it in this way. So let me redraw it. So we did this way where I got this group, and that group. We did it this way where I got this group, and that group. Which other possibilities there? So I could get this, that, and that. So this is a possibility, and I could show you how it's done, but then at the end of the day you still have the same procedure. But then let me show you another possibility, or another way you could synthesize. So it's more than 3, even though the question said show 3 ways. No, there are more than 3 ways you can do this. And then the last way would be to get this part with the alcohol group. But then let me show you another way you could do this. So one thing you could do is you could get this portion here with the alcohol group, the way we did it here. But instead here, instead of putting, making it a methyl group, I could make it an aldehyde. So if I did that, we'd start with an aldehyde that looks like this, right? If we start with an aldehyde that looks like this, how many groups are missing for us to get there? So for us to get there, the first thing that's missing is we're missing 2 methyl groups, right? But then I have a hydrogen group. Okay, so what we could do is our first Grignard reagent can add a methyl group like this. And so when we run that reaction, how will it look like? When we run that reaction, we'll have something that will look like this. Same story. Same story. This becomes negative, attracts the magnesium bromine like that, which is partially positive. So there's an attraction between those two like that. This is our hydrogen, and then that's the methyl group. We've just put this methyl group here, right? So up to this point, you need to know that no, you need to analyze first. For when I'm here, for me to get there, what else is missing? To start with, I'm missing a methyl group, right? But I have a hydrogen. So I need to use one of my reagents. If you watched my previous video, I discussed reagents and what they do. So there's a reagent that is capable of removing a hydrogen and converting that particular compound into a ketone. So that reagent is an oxidizing reagent. So there are many to choose from. So you need to know, another way I could have done this is I could have added my wake up, my hydronium at this point, and then it could have donated the hydrogen there. That means this would have been an alcohol, specifically a secondary alcohol. When you look at my previous video, one thing I said is that when you want to convert a secondary alcohol into a ketone, what do? You use a reagent called, yes, I'm sure you're correct, you use PCC. So PCC can change a secondary alcohol into a ketone. How? By extracting the hydrogen. That's what PCC will do. It will extract this hydrogen. And so at the end of the day, what will you have? So you have this compound. After PCC reacts, you have something that will look like this. The hydrogen will leave, right? And then here you have a ketone functional group. This is an oxidation process. Now the question is, what if you didn't want to use PCC? there are many other options you could choose. So the oxidizing agents, in the previous video I discussed potassium permanganate as the only oxidizing agent. I didn't want to give you all of them at once, but then you need to know that when it comes to oxidizing agents, there are many. So the oxidizing agents with the same strength as PCC, we have DMP, and then we also have chromic acid, which looks like this. DMP and chromic acid. So DMP stands for, if I'm not mistaken, it should be Des Martin Peridonen, something like that. Okay, so let me just write it for you. It's like Des Martin Peridinen. I think it's Peridinen. Peridinen. That's what DMP stands for. But otherwise, it's not very important for you to know what it stands for. But the point I'm trying to derive at is, at this stage, you could put any one of these and they would do the same thing. So if you don't want to put PCC, you could put DMP, or you could put chromic acid. It would do the same thing and extract a hydrogen. So let's go from there. What's the difference between this and there? Well, we are supposed to go. So you'll be able to see that we're missing a methyl group. So we can add that methyl group using a Grignard reagent. So this Grignard reagent will react there, and then what will it do? It will add one more methyl group. When it adds a methyl group, the story is the same, right? Same story. Yeah, I'm very tired of telling this story. Anyway, so for those who don't get it, what I'm saying is this carbanion will attack there. Once it attacks there, this carbon here will be bonded to 5 things. So we're saying 1, 2, 3, 4, 5. That's bad for the carbon. So one of these bonds has to break, and then to donate the lone pairs there. When oxygen has more than the required lone pairs, it becomes negative. This negative charge will attract the magnesium bromide, right? And then add some hydronium ions here, and then one thing you'll be able to see is you produce an alcohol. So that's how you synthesize 2-methyl-2-butanol. So the other examples you are given are pretty much the same. So there are some that are a little bit tricky, and then I'll dedicate a video specifically to those types of questions. But for those who want more help as to how to go about the retrosynthesis processes, I have a solution sheet that I prepared. So all you need to do is reach out, and then I'll be able to share it with you. Otherwise, this will conclude this video.